So now I wanted to go through some practical examples of classes. And so what we're going to do here is create a planet class. I guess I should change this to class or an object, but class is more specific. We're going to create a planet class that has attributes name and diameter and methods area and volume. So this is something we could have used in the assignment that we did, where we were working with moons and planets. So first we're going to import NumPy, because we're going to need that. And now we're going to create this class, planet, which is a top-level object, a top-level class. It doesn't inherit anything except for those standard things. It's going to take itself, so that doesn't require any arguments or parameters, but it'll take two parameters, which will become attributes. So when we create this class, we're going to need to provide those to the class, to the instance of that class. So we're going to have something called name and something called diameter. So these two things will then be stored as attributes name and diameter. And then we're going to define two functions. We're going to have a function area. That will not require any other arguments except for self, because we've already defined the diameter. So we're going to then just return the formula for area, which is 4 pi times the diameter divided by 2, or the radius, squared. That's the area of a sphere. And then we're going to also define this volume method, which is the same idea. It's going to just take the information that's already stored in that object, this attribute diameter, and it's going to calculate the volume, which is 4/3 pi times the diameter divided by 2, or the radius cubed. All right, so we're gonna now we're gonna instantiate the class. So we're gonna say Earth is this. We're gonna create this instance, this variable Earth, and it's gonna receive this output of this instantiating this class. So we have this planet class, and we're gonna pass two things, and these are defined based on the order in which we define them. So we can specify that directly, but let's just, we'll just pass them in order. And so we need to provide the name and the diameter. And the name, in this case, it's gonna be a string. It could be something else. We're not specifying what type it is, but we know that it should be a string so that it's useful to us. And then we have a diameter, and we know this should be numerical, probably an integer or a float. The class doesn't care. It will try to calculate this however it can. Python is dynamically typed, so it will try to just take whatever information we give and calculate it, but we want it to be an integer or a float. So we're going to create that instance. So if we then look at this attribute, earth.name, I did not clear the output so you can see what the output's going to be, but it's going to have this value string this value earth, which is a string that we just created, and it has this attribute diameter. But where it, well, let's just, I think I can select. You can do a shift click, and it will select multiple cells, and I can go current output clear. So if I want the area, I can type earth dot, and so it has these 4 attributes, area, or these 4. 2 of them are methods, 2 of them are attributes. So we have the diameter attribute and the name attribute, which we just saw, and then we have the area and volume function. So if I want the area, I can just type earth.area with parentheses, and it's going to run this function using the attributes that it has stored as it's defined. If I want the volume, it'll give me the volume. And these are just going to be in the units of however I passed it, which I think is kilometers. So these would be square kilometers, and these would be cubic kilometers.
So in it, that like specifies how to read what you put in.
Yes.
So then, okay. And so I tried just for the sake of it.
Yeah.
Putting in like 3 values.
Yeah.
It says that they expect 3 before we're given. So does
Right.
that self count as the 1 extra?
Yes. Yes. So self counts as 1. So sorry, if we type, let's just see here. We can play around with this. So or I can do So it takes self counts as 1 positional argument, which is the the 0th or first argument, and then we have the 2 that we asked for. Now I think this should work too. So we can also put these out of order if we use label-based assignment. Right? It's the same idea as with a function. So you can have positional assignment where it's just you put them in a certain position in this function definition, and so when you initialize, it will look for them in that order. But if you want to put them in a different order, you can just use this label-based assignment. So this works, but if we did if we did this, it won't give us an error, but the name will be the diameter, and the diameter will be the name, and then we can't calculate these methods because it's a string. So let me just add this here to the Right. Okay. So let's look at inheritance now. So we're going to create a class Moon that has all the same attributes and methods as Planet, because these are just spheres in space, right? There's nothing really fundamentally different about a planet versus a moon except for their relationship to each other. So we can create a class Moon that inherits all the attributes and methods of Planet. So we can just do that, say class Moon Planet, and just write pass. So it doesn't have anything else to it. However, let's do this. Let's also do one more thing. So let's not do that. Let's actually give it something. So we're gonna say it's going to take let's call it host planet. So we want Now I might have bitten off more than I can chew, because let me see. Oh. Yeah. Okay, let's not do that, because I need to think about how I would do that. That will be something I'll try to add later. So what I wanted to do was add an extra attribute, but I'm not on the fly. Can't recall exactly how I want to do that. So let's just leave it as is. But what we want is, here we have a moon class that has all the same attributes as the planet class. So here we can instantiate that moon class. It has a name, a diameter, an area, and a volume. So it works the same way. It's just inherited all its properties. And yeah, maybe during the break we can look into adding some more attributes to that subclass. The last thing here is I wanted to talk about built-in, some other built-in functions with classes. So in addition to init, we have some other options. So this is an example where we're going to create a class called book that takes values for the author, the title, and the ID number. And so this class uses a number of special built-in functions to control not only how these instances of the class are initialized, which is using the init function, but also how they are officially represented as strings using the REPR, how they are informally represented as strings. Remember, we saw kind of the raw or %R rendering, or when you type the string variable name but you don't type print, that kind of thing. So it's how it's informally represented by strings, and then how equivalence operations should be evaluated. So we're going to define this class book, where we have the initialize the author, the title, and the book ID. We're going to then define this representation, so the kind of how this object will be represented when you just type the name of the object by itself without printing it. It will give you kind of the basic information about that object. We can also see how it is printed as a string, and then how equivalence is done. So these are just this kind of official representation is done using the string formatting. This informal string representation is also done using string formatting, and then the equivalence operator says that two books will only be classified as the same book if they have the same title, the same author, and the same book ID. So what we can do is we can instantiate an example of a book. So this will be called Iliad. This will be Homer, the Iliad, and then it has this like ISBN number. So when we just look at Iliad by itself, first of all, we can see Iliad dot author, Iliad dot title, and Iliad dot book ID. Right, so that's just the attributes. But how are they represented? So if we type this, just the name of that variable, we're going to get it represented. It's going to say book, and then in parentheses the 3 values. This is just how it's represented, so it'll tell us what values are stored there. And we have control over how that's done using this REPR special variable or special function. So we can see officially how that looks using the REPR function. Same thing, if we render this as a string, it will, let's see what happens also if we do. So it will, it will print it as the author, comma, the book title, comma, the book ID based on this command right here. Finally, if we create a book which has the same author, title, and ID number as the one that we have already created, and we compare them with an equivalence operator, it will say true, that those things are the same thing. But if we change this to another number, they will not be the same. Even though they have the same title and author, all 3 have to be the same. So these are just ways you can customize your class further to see how it will be rendered in different contexts and how equivalence operators will work, for example. The last thing for this lesson is I wanted to talk briefly about coding style. So we've seen a lot of this in the class so far, but so Python is meant to be easily readable. This is from Wikipedia. So its formatting is visually uncluttered. It often uses English keywords where other languages use punctuation. Unlike many other languages, it does not use curly brackets to delimit blocks, and semicolons after statements are optional. It has fewer syntactic exceptions and special cases than C or Pascal. So the way that Python is defined, the way that the syntax is kind of codified is through these Python enhancement proposals, in particular one called PEP8, which was the 8th one. You can click on this to find more information, but it defines the style conventions for Python code. Functions that are part of classes are called methods. They're the same thing basically, but the convention is that you should name the function after what the function does instead of like a command you're giving. So mylist.pop pops off the end of a list, not remove from end of list. Keeping them simple and small, short. Class should use camel case, which is where you have upper and lowercase all smushed together without any underscores. So this is the standard thing, but your functions should use underscore format. So using underscores, not dashes, or camel case. Be consistent with how you organize your function arguments. So if you have one function that takes the functions in the order dog, cat, user, don't have another function that takes them in the order user, cat, dog. That will just create confusion. Of course, as we saw, you can use keyword arguments rather than positional arguments, but it's better to use consistent ordering. Try not to use variables that come from the module or global variables, you use your own names, and yeah, we saw use class when you create a class, call it object. So we'll do this. So you also want to use vertical space between lines in places to highlight blocks of code, and horizontal space so it's more readable. And you know, if it's hard to read out loud, it's probably hard code to read. And we didn't talk about spaces, but as we've seen, when your blocks of code, they should have 4 spaces. Typically we use 4 spaces. You can use 2 if you want. You can use tabs. 4 spaces is preferable to when you indent your code. And the notebook and IPython and probably your text editor also will all help you do this. Most of the modern text editors are pretty good that way. Finally, comments. You should write comments to describe what you're doing, and importantly, why you're doing it. This is important when you're writing a project or some code. You're probably in a hurry. You're probably just trying to get it working so you can turn in your assignment or finish your project or get on with your day. But taking those extra 5 minutes to write comments in your code is doing your future self a huge favor, because when you go back and look at that code in a month or a year, you will have no idea what you were doing if you don't put comments. It'll be much, you can, because Python is more readable than other programming languages, you can maybe figure it out, but it will be much faster if you write comments in your code. If you write doc strings, which define the functions and the other things that you do. So take the time to write code. And it's not just for yourself, it might be for someone else. If you put your code on GitHub or you're working in a collaborative coding environment, someone else is going to need to understand your code and what it's doing. And you know, don't go overboard on the comments either, though, because the more comments you write, the more you have to maintain them. If you change your code, you need to change your comments too, right? That often can be forgotten, and so you want to make sure that your comments are succinct and clear, and then you'll be in good shape. So that is it for modules and classes, and then our last lesson we will talk about Git and GitHub.